Hi all, welcome to this, our second video in the Biosphere series, in which we're going to be looking at our first soil profile, and that's the soil profile associated with a podzol. Now, with all of these soil profile videos, we're really only going to be focusing in on one slide, and they're all going to look fairly similar to this. Now, one of the first things that I want to say now, and I'll probably repeat this in the remaining videos, is that this is one way to represent the soil profiles, and it's not necessarily the way that I expect you'll elect to represent them. I do encourage you, look online at other examples of how the soil profiles are drawn, look through different textbooks, etc., and find the representation, the visual representation of the profile that works best for you. I'm going with these representations because, well, one, they happen to have a lot of information on them, and two, it's just a reasonably nice, neat, condensed way to allow us to discuss through it in these videos. So with podzols, the first thing that we always establish is that in podzol environments, we are looking at places where precipitation is greatly in excess of evapotranspiration. Now that's really important because it leads to one of our main points, our main processes that's going to be going on throughout our podzol, is that we've got a huge amount of leaching and translocation associated with that. So we've got very, very distinct soil horizons. We've got a very, very clear A, B, and C horizon throughout this soil, and that's important, and it is a point that you should make sure that when you're writing up your example for what a soil profile is, or what this soil profile is, we make it very, very clear that we've got three distinct horizons. Now, above our soil on a podzol, we are, in terms of the kind of context that we consider in Scotland, we are really thinking about coniferous woodland primarily. Yes, there are other examples, you see a couple noted in the slide here, like moorland and acid heathland vegetation, but we focus in on coniferous woodland. So if we move down through our layers, we go into our different horizons, our O horizon. Now obviously we've got our leaf litter, as I've said, we're talking about coniferous woodland, so that's dominated by the pine needles that are associated with that, and as these ferment and they turn into humus, they turn into a very acidic moor humus. Now this is important because in terms of fertility, it is slightly more limited than the different types of humus that we'll discuss when we talk about, for instance, brown earth soils. But we do get a very distinct humus layer, which obviously has some nutrients that it can offer. However, a lot of that, as we've said, is going to be removed from our A horizon or our O horizon through our A horizon and then beyond into the B horizon by leaching. Because we've got a precipitation greatly in excess of evapotranspiration, we've got free-flowing water throughout the A and B horizons, which is going to drive these nutrients down and through. Now, as I've already stated, this is going to mean that we're going to have less fertility in this horizon. In addition to this, it's also going to change the colour of the horizon, and this again is something that you should be sure that you make reference to. So the A horizon in podzols tends to be quite kind of whitish or grey. It's described here as being bleached, which is a very, very fair description. And that's because the chemical compounds that bring the colour out in soil, particularly the kind of the reds and browns, are largely associated with iron, and that's one of the key elements, the key minerals that are driven down through the soil by leaching are the iron heavy ones. So as we move, as I say, we're losing a lot of these nutrients through alluviation from our A horizon down into our B horizon. And there's some examples on the slide here of some of the things that we're losing. Very noteworthy is kind of sodium and potassium. These are elements that are very, very important for fertility in soils. And we're losing them out of the A horizon, down into the B horizon, down into the subsoil. Now, as we move into the B horizon, in a lot of podzols, you get a very, very clear marker of your transition from the A horizon into the B horizon, and that can be in the creation of an iron pan. Now, an iron pan is very much what it sounds like. It's a horizontal layer where a lot of the iron that was moving down through the soil profile, it mineralizes out. And it can create, in some instances, a very literal layer of iron. Now, that can have a couple of different impacts. One, for us, it's fairly convenient in that you can then look at the soil profile and say, aha, there's the area where it transitions from the A into the B horizons. But in addition to that, it can also present an impermeable layer or an impermeable barrier to moisture, which can result in leaching in terms of minerals moving from the A horizon into the B horizon stopping, but it can result in a lot of bogging down and it can result in a lot of waterlogging of the soil, which can have some very pronounced consequences, which we'll discuss further when we look into glaying in a future video when we look at gley soils. And it can result in minerals and nutrients being moved horizontally along this iron pan rather than vertically through it. However, we are also going to see, as we've said, we've got our eluviation is moving, it's coming down through the A horizon into the B horizon where we see more eluviation, and these nutrients are then deposited again, and we'll start to see this area become a lot more richer in colour, a lot more browns and reds coming out because we've got more iron in this area. And we might also see different kind of clay materials and stuff be deposited in this area as well, which again can result in it becoming less permeable and resulting in more water moving through this layer horizontally rather than vertically. As we then move down into the sea horizon, we're going to see again we've got a lot of water is still trying to move down through the soil. It's going to hit this the parent material or sea horizon, and then dependent on the nature of the parent material, it's either going to move down through that, which is going to take these nutrients all the way out of the soil profile, or it's going to start to move along it as through flow. And the difference there is going to be whether or not the soil is permeable or not. If the soil's moving through, if the moisture is moving through the sea horizon further down into bedrock, as I say, we're just losing these nutrients and they're going for good. Or if it is moving across it, then yes, the nutrients might come back into place somewhere, but in terms of this one vertical profile, they're certainly not something that's of huge amount of use anymore. Another consequence of that is that any materials, if we did have any kind of capillary action going on here, you would potentially start to see some of the minerals that are found within the parent material in the sea horizon come up through the soil profile and become available to plants and whatnot to use. We don't see that here because the vast majority of the moisture is moving down through the soil profile. Now, what are some other things that we can mention about podzols as well? One of the key ones that we would consistently mention is that because we are talking about areas where we get coniferous woodland, these tend to be colder, more upland areas with lots of precipitation. We don't have huge numbers of soil biota in these areas either. And because we don't have these vast volumes of living organisms in the soil, we don't see huge amounts of mixing. And that's another reason why we've got such pronounced horizons in this soil profile. Now, I'm going to wrap this one up here, guys. The next video, we're going to be looking at our next soil profile, which is going to be a brown earth. And until then, I'll see you guys later. Bye.